idea?
George's idea is a long trapezium.
Long trapezium. What? How'd you get?
Do you want me to draw it?
I was thinking creatively.
Why does it have to be a trapezium? Maybe
It
like
doesn't
a
have to be
rod.
trapezium,
A long
but I-
trapezium. That's how long one.
How do we do this? Actually, is it possible with this? Oh, maybe the trapezium is making it harder. Just slanting
Pretty
it away.
sure for any trapezium, or for any long trapezium, you just have to like get the circle awfully close to the two sides, like the two sides,
Awfully.
and then it will automatically work.
So is this your idea? Long trapezium?
Very long trapezium.
Like this?
Yeah.
Wait, should we approach this from the circle intersecting all the corners, or the circle being tangent to all the sides?
What? What is that in the question?
No, like I don't know.
Oh, I see. Yeah, so is your idea basically like if you have a big, you have to have a big circle to do this, right?
Yeah, a very,
Big
very,
circle.
And by the time it gets to the side, to the sides, it'll have to be kind of vertical or tangent.
Wait, so if it's a straight line, then the quadrilateral is also a straight.
Hmm.
There should be. Alright.
So now we don't know if it works, but we're now leaning towards the answer being
Okay.
no.
so-
Yes.
wait, what? Why is it no?
The answer should be yes.
Oh, by the way, you know the 12-point qualifier? I think that applies to A level too, right? So if you just do question one, oh yeah, it's hard to really just do question. Question one's not that helpful, is it? You do question 1 and 2, you don't qualify.
I don't want to.
But if you do question 1, 2, if you do just 2 and 3, you'll qualify.
Let's
Wait,
see
I
two.
think that year I did
Two is
like
just
I got 13.
don't.
Yeah. Which year was that? A while ago?
Last year the
Yeah.
wait no, that's the online.
Yeah.
Yeah. I mean, your name was on the website like for 2 years ago.
That one. It's just the one. I have
Yeah.
one very, very long parallelogram.
Is it better in
Really?
in a math competition to think it doesn't matter or think it does matter?
It's better to think it doesn't matter.
Okay.
Well, see, it
I
depends on what kind of maths competition it is. Like, if it's a maths competition where like the questions are routine, right? Where like so the thing, like if you're on, so this is a psychological study, right? If you're under pressure, you tend to do the things that like are more routine and you're
Yeah.
already good at better, yeah. And you tend to do the stuff that you're not very good at much worse, yeah. Whereas like something like being creative or kind of coming up with a solution is very much hindered by pressure. Okay, so if you want to like kind of just think about problems creatively and come up with nice solutions, having sort of no pressure on you is probably the best. Oh, that's a good parallelogram.
There's a ruler.
There's a line thing.
There's a ruler thing.
Hmm.
In option.
Yeah. Okay, so this idea looks like it works, yeah.
Square root.
So how do we
Yeah, that's no.
prove it? How do we prove that no circle intersects?
Well, it has to like tangent. Well, not tangent.
That's distinct, right?
How can we prove it? So even the people who've done this question, I think you might not have necessarily proved it that well, maybe.
Should we, like, try and find a point that we should expand the circle from?
What do you mean?
Try and find a good center for the circle.
Maybe. I don't really know where you're going with that, but I'm not gonna shut it down just because of that. No. Well, there's one thing I know is like it's not very easy to have a cyclic quad. Like if you have a circle that goes through lots of points, right? You actually get like a cyclic hexagon, right?
Mm.
And part of it is a cyclic quad, yeah. So the cyclic quad, it's not very common that you have a cyclic quad where the top two sides are parallel, right?
Well, only if it's
Long
Yeah.
trapeziums with their symmetrical.
Mm.
You can still do it because you can make those. DS component. To big T.
All the quadrilateral.
Two are like this.
So
Well, like-
the-
Like you can get 2 points which intersect the circle, and then we know that if we get the perpendicular bisector of the chord, it interacts with the center of the circle. So maybe if we prove that if we get a point that such that is impossible, maybe.
Mm. Okay.
Mm. The inside needs to loop in before the outside. So we're trying to keep the perpendicular lines from the center to the sides as close together as possible. Like the length of the nice. Okay, so the difference of
Mm. Yeah, so this is what Lucas was saying. Like, if you have like a circle, the center lies on the sort of like the vertical line, right? And then like these ones kind of look like they're not gonna quite.
well, if you try
okay, so if you get a long parallelogram.
well, be best to put like the center of the circle in the middle.
Well,
What is the middle? That's the question.
So
Well, it's parallel.
yeah. So yeah, so now we're talking about the center. So this is all your ideas combined, yeah? So you have Lucas's idea. The center is where the perpendicular bisectors intersect, right? So it's going to lie on some line parallel to that, right? It's going to also lie on some line parallel to that. And it's going to lie on some line parallel to that. Yeah.
That is interesting. Because like the circle has to be roughly tangent to. Because if it's like if the parallelogram is arbitrary along the circle, is basically a line, so it has to be roughly tangent to the sides within it.
Yeah. So is it clear that not only does the perpendicular bisector, so this thing has to be, they're parallel to the ones on the other side, right? Because they're both perpendicular to parallel lines, right? But also that they have to have the perpendicular bisector has to lie somewhere between the two vertices, right? You know what I'm talking about? It has to lie in between these two vertices, right? Because that's where the circle is intersecting. You know? Can someone try to finish my argument in a coherent way?
So it's the difference of squares, literally.
Huh?
Oh, so pretty much does any number with. Wait, but then that's wrong. So
Yeah. Actually, you could like chord bash this too.
Oh no, I don't like it. I don't
Because
like
like
it.
it might give you a good way to express what it means to be far apart. It's like
Because it's like quadratics or something, and it has to have two solutions.
all right. So anyone want to finish this argument off, including Crystal?
What
Can
is
do
this
it.
argument? I don't get it.
Well, so the argument started off with George saying you could have a long trapezium, which then became adapted to a long parallelogram. Yeah. Okay. And the idea being is like it's kind of really annoying to put circles, like through those 2 points, right? And then Lucas gave a more sort of, so he added onto this idea some ideas for maybe making it into a proof. Okay. So he's saying that the center of the circle, which I think Kevin also mentioned as well, is going to be where the perpendicular bisectors intersect, right? Okay.
Wait, does it?
Huh? Oh, did you know that?
I read the proof.
If you have a circle, right?
I read the proof. I would be like saying.
The center of the circle is on the. You read the proof, or you wrote the proof.
No, I read the proof.
Oh, reading the proof.
I read.
Wait, that's not very nice.
Wait, when
Yeah.
did you? Where?
Oh, she printed it. No, she printed this out because she thought the
She-
A level. She thought the A level was like this A level was on Saturday.
Oh,
But it was actually the O level one. I was like, why you stupid? And she's like, I don't know.
well, I mean, I already kind of organized it for you, so you don't have to really do much on your own.
No, shit. Do you not get spanked after you call off stupid?
No, because she's used to it.
Bro, my mom would like slap me.
As a parent.
Yeah, and look at the problems it's caused. Okay, so do you know that if you have 2 points on a circle, the perpendicular bisector is what goes through the center, yeah?
Yeah.
So there's going to be some points on this long parallelogram where the perpendicular bisectors.
Ah, okay. Well, they're always pointing in this direction, and it doesn't.
Yeah. You see, I don't want to spoil it, but like I can't. I'm kind of a little bit frustrated. No one's finishing this off.
I don't get it. Okay, so like you have to prove that no matter how much you move the side two ones, they're never gonna intersect.
No, you don't have to prove that. You just have to prove that you can move it so that it doesn't intersect, right?
What is? Like,
You're not asked to prove that it never works for like long parallelograms. You just have to say like some long parallelogram for which it does not work for, right?
yeah, that's what I said.
Or some convex. So I guess if you wanted to be really rigorous, you might want to prove that this is a convex. See, another reason to chord bash.
Dang it! I don't like this. I don't like this.
Yeah, so I think when you practice more than you need, when you get in the exam, you won't feel so deficient all the time. Yeah. So if you're in year, maybe if you're in maybe the fall will actually get you to sit like an exam. But if this is your
Yeah,
first
let's
exam,
see, chord bash.
We bash chords.
We said, I don't know, we said origin to that one. I don't want to do.
okay, well you have to get the idea first, and then you might wonder how to write a proof. Yeah.
Well, we know parallelograms are great for chord bash.
Crystal, please spoil it for us.
No.
Spoil the proof of this. Why a long parallelogram cannot have a have a circle that intersects it properly.
They can't be the same line, and then they can't intersect because they're parallel.
Ah, yes. So if these two are parallel, right?
It's not.
These two are parallel, right? The only way they can intersect is that they're the same line, right?
Yeah, but they're not because long.
They're literally.
They're not because long.
It's
Yeah.
parallel.
They're the same line,
They're
but that has to be a
parallel.
rectangle.
Yeah, they're not because long.
No, because it's a short.
That's a fake
Well,
solve right there.
Yeah,
But
but
it
it's
doesn't
not
have to be a
path, so
rectangle
nobody
because
cares.
if you look at the other direction, it is the same line, right? Like if you look at these two parallel sides, you do get that's the same line, right?
Yeah, but
Yeah.
the other two aren't, which means die.
But like the.
But that's because
like,
there's lots of space, right? But when you go to the other lines, well, look, they're so far apart, it can never be the same line, right?
Is it best to like logic it out or chord bash?
Oh no. I think if you're in the exam, it's definitely best just to hand wave a diagram, because like it's question 1.
Uh.
But like if you're at home practicing, I think you want to actually write a rigorous proof. Does that make sense?
Yeah. How to rigorous this? So you have to construct two. Okay, so to construct a parallelogram, get 2 points,
Yeah.
and then duplicate those points to like on the line, and
Yeah.
then move it perpendicularly down. So like when you move it on
Yeah.
the line. Okay, so if it's AB and then there's CD,
Yeah, like you just need to find 4 points such that any line here on any of these,
And then that's how you can
it'll never
start-
intersect any of these lines, right?
and then it won't intersect.
Like you don't have to, but that's one way to go. Yeah. Okay.
And then
Yeah.
you have to prove it's cross and I don't.
Yeah. So if you kind of get good at this sort of stuff, I think you can do question 1 in like 10 minutes. Okay. And you can have it written up in like 15 minutes. So, and if you're kind of just like seeing it for the first time, but you've got that right problem solving ability, you could probably do it in 30 minutes. Okay. But I think it's important to sort of roughly know how long it'll take you to do question 1 when eventually you're like kind of going for gold, because there might be like a situation like this, like you're in the fourth hour, right? You're at the 4th hour, you solved 2 questions, okay, and you're stuck on the 3rd question, right? And maybe you're really ambitious, you're doing you've solved question 3 and 4. Oh, how about this? You've solved question 2 and 3 and you're stuck on 4. How about that? Yeah.
Yeah.
And then you get to like the 4th hour. What do you do? Well, like if you know it takes you half an hour to do question 1, then the 4.5 hour point is your real decision point, isn't it? Because at that point, like you're at the point of no return. If you decide to like not do question 1 from that point, you're kind of just giving up on question 1 and committing to question 4, right? But you might see that you're not getting anywhere with question 4. You have 30 minutes. You end up doing question 1 and salvaging 4 points, right? You send your tape paper to Russia. Why is it whenever I'm epping, it's so exam oriented? Okay, so you understand what I'm saying?
Because exams are what give our parents success.
Yeah, but I mean, we had this without epping, and the parents, I tell them we don't care about exams, and they're fine with it too.
I don't think we're in Epic.
We are nothing.
No, like what from Epic. We're in Epic.
All right, let me put up the second question. So this is one most people are interested in, right?
Yeah.
So I'm hoping we can basically team live solve all the questions at the beginning at least.
Wait, question 2.
You guys.
Question 2.
Four is just.
All right,
Four
question
is
2.
just-
Yeah.
Like riddle.
A pair of distinct integers, positive integers, is called nice. Yeah,
The parity is the same.
yeah.
If
And maybe
it's
English will
nice,
collaborate with maths, and you have
it's
different
nice
adjectives.
If you turn it upside down,
So if the arithmetic mean and geometric mean are both integers, so A and B are nice if A plus B on 2 and A times B square root are both integers, yeah? So it doesn't, A and B don't, oh, they do have to be integers.
okay, idea for this question. So
Then I guess they'll have to be positive integers, so. Okay, and the question is it true? Yeah, actually, also in lots of the early questions, the examples have been kind of prevalent recently. Is it true that for each nice pair, there is another nice pair with the same arithmetic mean? Oh, okay. So you don't. It's unordered pair, yeah. So you don't care about the order of the pair, obviously, or the question will be trivial.
This question really feels like Pythagoras stuff.
So does A, B, nice mean there exists C, D, nice? Yeah, that's kind of the question.
Dang it. 5 plus 3. So 5 is n, and then